All right. Okay, welcome back to week 17, lesson 2, explaining machine learning models with model explainers, Coding Dojo. So today's lesson is very interesting. Announcements, reach out on Discord if you get stuck. This is the channel. And in your BELT exam, you are allowed to use the classes or LP function use allowed, but must be site source. And you can also use the functions on assignments if you want. Okay, but it should be in a very good form, writing, commenting, or everything, because it is going to be your like portfolio project whenever you are going to use it anywhere. Assignments. So this is a required core assignments. Before that, like from the before you join the next lesson next week, it is recommended if you go through the reading of preparing wide form timetable, time data, plotting data with different units, time series, and resampling. If you go through these topics before coming into the next live class, that will be very beneficial for all of you. Core Project 1 revisited importances and coefficients. This is the first core assignment. And Core Project 1 revisited global explanation, second one. Core Project 1 local explanation, this is the third one. These all assignments should be submitted by tomorrow, Friday, 9 a.m. EST. This is a deadline. And we are going to covering up these today, the global one and local one explanation. So before moving ahead, let's do 3-minute breakout room activity. In this, you need to click here. I will share the link in the chat as well. You need to answer these two questions. Do we need to scale the data before applying the feature importance? If yes, why? How is a model prediction different from a model inference? So you can write down in 1 or 2 line or maybe 1 line. Okay, you have only 3 minutes. So I'm going to open up the breakout room. Okay. Hey, Daniel.
I think that's all they're going to talk about today, Nurja.
I had this question, the scaling one. Guess I forgot to resume the recording.
Sorry, Nerja. It's raining real bad here, so I keep losing you. But I can hop into one of the break rooms are closing. Never mind.
Yeah, I just
Man,
saw.
epic fail. I'm sorry.
It's okay. All right. Okay, from room number 1, who is going to explain about it? And which feature you interpret? Anyone? Anyone?
Who was in room number 1? I don't recall.
Okay. Okay. So I will explain about it. If we talk about the bathrooms, okay. So here you can see the higher value, the larger value on the right side, right? So it is contributing in predicting good, higher predictions, right? Because highest the value on the right side. But we can also see on the blue dots, few blue dots here as well, okay, in some cases. And then the floor is also contributing lot, right? Because its prediction power is very high. Red dots are on the right side,
Right side.
right? And positive, right, means positive, right? And bedrooms, this is on this side. So this means when the number of the bedroom is increasing, either it's we can say it's increasing, but what will happen in that? It is lower the prediction power. So this means if higher the number of bedrooms, lower the price of the house. It will start dropping the price of the house. Okay. So this is how you can interpret the result of the using SHAP of each feature. Okay. Now we will move ahead. Till so far you have seen the in this SHAP was taking the whole data set. Okay. How it takes in the part of the whole data set, I will show you in the code along. Okay. Using Python. Now we will talk about the local explanation. What is the key difference? Now, if you want to jump for the specific data point of the feature of the row, then we will jump onto the local explanation so we can understand it more deeply. Okay, this is we are looking overall, right? But now, if I want to really see the, let's suppose here on this force plot, right? I want to see how much it is contributing the bathrooms if bathroom number is equals to 4. If any house have a bathroom is equals to 4, so I become very specific now. Earlier I was looking at the total number of bathrooms. Either it's a 2, 3, 5 whole data set. Now we will become here specific. This is square foot living, right? And this is year bed, bedrooms. Here the floors. In this force, like the plot, this is the base value. Okay, the intercept value, mean of your white ring. Okay, and this is your actual value of the house. Okay, this is predicted value of the house. Okay, now we can see bathroom square foot living this much is pushing towards positive, predicting higher prices, right? Correct prices, helping to predict the prices correct. here. Here the year bit is pushing towards the negative, right? So this means when your data point is, when you have a case, bathroom is equals to 4, square foot living is this much area, and year built is 1960, bedroom is this, floor is this will be the price, right? But we can see in this case, which feature is contributing a lot in predicting the price, higher prediction power. Bathrooms, this number of bathrooms, and this is the area of the house. Okay, so this is the specific case how your SHAP we use for the local explanation. Okay, what questions do you have? Any confusion in local explanation and global explanation?
I would like to see that in the corner along to get more clear, I guess. Yeah, it's fine. It's said maybe in the corner along probably with a practical example would be more clear, I guess. Yeah.
Okay. So now we will talk about the local interpretable. Okay. So in this, this is a line one. This is only and only used for the local one, not global. Okay. Look at this. This is a global, right? This is a non-linear, like the data. Right here, you have the few points here, the plus one. This is the dots on the right side, right? But I want to look for, I'm not interested in these points. I'm interested to look at this point only. Okay, from the whole data set. So whenever I will apply the line on these or SHAP on these, this is the single data point of my data set, right? So how each feature is contributing in this prediction, right? In one data point means I'm talking about one row. Okay, so this will be this will focus like this, the line will focus like this, and it will generate the new samples, predict the new samples around it, and then give you the result. Okay, so how it will do? In line, it can explain many types of model. It can explain tabular data, it can explain text classification, it can explain image classification. Okay, so Lime supports these kind of models. Okay, Lime can apply on any model. This is a agnostic based model. You can apply on any model. And SHAP is also built up for classification, regression, both. Okay. Now look at this. This is we are explaining with the tabular data only. Okay. Now in this, what we are looking at it. Here, we are just using the Lime tabular explainer, right? And this, when you explain the specific point, this is contains this graph, it will tell you the negative and positive, like the predictive power. If it's a negative value, low prediction. If it's a positive, higher prediction. In this house sale price, if you look at this, you can see we are again considering the specific value, right? If this is a area of the house, 2,690 square feet, and the waterfront, your line is telling you if the square foot living area is greater than this will be the price of the house. Okay, this has a higher prediction power. It includes if the waterfront value is 0, then the price is this, right? So you can see here how it is interpreting, how each feature is helping in predicting your output. But if you look at this, on the other side, this one, the year built, number of floors and bedrooms with the same, you have like features in one row. In the same, like the row data point, the year was given 1949, floor numbers were less than equal to 1, bathrooms were 2.5, and bedrooms were greater than 4, then this was the price. So you can see the price is dropping, right? It is predicting the lower prices if this is a year. But on the other side, square foot living is giving the higher prediction. This will be the house price. So this is helping us to know about locally the single data point contribution of each feature, right? If this is the value of square foot living, the prediction power is higher. It is predicting the house sale price this much, right? But at the same point, if your year built floors, bedrooms value is this, it is pushing it down, right? Doing the low prediction. So this is the difference, like in the Lime and the SHAP, the local interpretation. Now it will make you more clear when we will jump into the code along. I have already opened in my local environment. So here we are using the same data set which we have used in our lesson 1, life expectancy. We are going to continue that. So this is the same function. I will not repeat it. We will jump on to the here, from here. Okay. So we have in the first class, we have saved our model in the joblib as a joblib file, right? Inside one file. Now how you can load it? You will load it using joblib.load your file name. Okay. And this is a keys. If you remember, we saved these keys. 2 models, your preprocessor and data. And then how you will separate it? You will make a saving into the separate objects like this way. Okay. After loading, you need to separate it. Okay. Now, when I ran this evaluate function to check it if everything is working okay, so it throws me this error. Could not convert string to float. Can anybody tell me why this error is coming?
Yeah, maybe there is a value that is not formatted as a number. I have to be cleaned up.
Yes, Rodrigo, great, right? How we will clear it?
So we need to identify which is the value that has the problem, correct? It has maybe an extra space or a character, correct?
This is like you are developing, right? So it's a categorical one, right? And we save the preprocessor as it is, right? We did not apply the transformation at that time, right? So we need to apply the one hot encoder. Okay. So this is the one. Now see, when I did the X train head, it is showing in this. Okay. So now we will take the features name. This is same process, right? For your train and test. And we will convert it into transform your X train X test data using the preprocessor, because we already made the pipeline in the first lesson, right? Because we are using the same processor, preprocessor. We are not going to build it again. Okay. So we will transform the X train X test here. That's fine. And now our data is good to go. Now we will check the evaluate. This is working fine. Train and test accuracy giving fine. You can format it using the same lambda function here. Okay. Now we will get the coefficient of linear regression first. Okay. So these are our coefficients of your linear regression model. Now look at this. This is the same graph which we did in the first lesson, right? Which features are having more important than the other, right? This is negative relationship. This is positive relationship with your target. Okay. Which your income composition of the resources, schooling, infant deaths, how it is contributing in predicting the life expectancy. Okay. So this is positively related with your positive relation with your target in this. Now we will evaluating the same with the random forest. In the random forest, we can't do the linear coefficients because it's other process. This does not contain any your y is equals to mxc plus equation. So here the top features are HIV, AIDS, This is the one under 5 deaths, schooling, thinness. This is the top to bottom, its list, ranking. So which has the highest predictive power? HIV, income composition, under 5 deaths, schooling, right? So this is, we are looking at it globally right now. We don't know like which feature is, which value is contributing, right? At which your model is saying this is helping. Now we will jump on today's topic, that is permutation importance. Okay. So in this, how you need to do, you will import sklearn.inspection, import permutation importance. Okay. So this is the library. We will apply the permutation importance first on your random forest regression model. So here, look at these feature parameters. This is model name. This is your test data, right? And we are applying it the permutation importance on test data here. Okay. So scoring is equals to, this is, you can use your R2 score, and number of jobs is equals to 1, -1. So what does it mean? This parameter helps, as I mentioned in the, like during the slides, your permutation importance take too much memory, too much computation power. So if I say here number of jobs is equals to -1, it will use the all preprocessors of your like CPU, okay, to calculate it faster. If you say here none or 1, this means same. If you don't mention anything, you say none, it will use only 1, your like preprocessor. Okay. If I say -1, it will use all parallelly. Okay. So it will do that job. So here we set the random state is equals to an seed number, which I have set at the top. This is your keys for this. Importance is standard deviation and mean, which is it is going to use. Here we will convert our result after applying into series. And we are also taking the here name out from the model. If all of you remember, when you want to take out the name from the model, you will use this method, right? Features underscore names underscore in underscore. Okay. And look at this. This is the permutation importance score, right? So which feature seems for you contains the, which feature contains the highest permutation importance score? Which feature may impact a lot your model? We can also look at the graph, right? So HIV/AIDS, if your permutation importance is breaking down the relation, shuffling when using this feature, this is impacting a lot. It is decreasing your model accuracy, down performance. So this means this feature is very, very important for your model. Okay. So it is reducing the power of prediction. Okay. And then after that, income composition of the resources, under 5 depth, thinness, and so on. Top to bottom, it is showing the importance of each feature, right? Using the permutation importance. Okay. Now, what questions do you have till so far?
I'm trying to follow. Yeah, there's one question in the line 32. In that function, there is importance. Line 32. Okay, it's, the input 32. This says importance. Where you calculate this importance?
This is simple feature. This is feature importance. This is permutation importance. I'm just trying to show the difference. So when you applied the feature importance, which feature was important for the model, and when we applied the permutation importance, which feature was important. Okay. Now you can see here HIV/AIDS, income composition of resources, under 5 death. If we consider first 5, thinness this. But if when you applied only the feature importance on random forest regression, then the features are coming this. Under 5 death is coming at number 3. This is also at number 3. But the schooling is coming at number 4. But for permutation, the infant death is coming here. Sorry, this thinness. Okay, so you can see there is a difference, right? When you applied the different tools on the same model to check the importance of the feature, it is showing you the different result. Did I answer your question?
Yes, and how we know which is better?
Which is better, you will come to know. We look always from top to down, top to bottom. Okay, so if we look at it here, the HIV AIDS is have a most predictive power for the model because it is coming at the top. You can see here at the bottom x-axis, this is the importance, right? This is more than 40, or you can say going up. Okay, this means this feature has a highest predictive power. So when the permutation applied on this feature, when it shuffle this feature, break the relation. So this is impacting lot on your model prediction. That's why it chose this feature. Okay. All right. So now you can apply permutation importance on any model, as I have told earlier as well. Now we will apply the permutation importance on linear regression. This is the same way you will apply. Only I change the one parameter here and repeats is equal to 3. So what it, I want to repeat the shuffling process for each feature 3 times. Okay, 3 times. So when it will consider the first feature, it will shuffle it 3 times. Then second 3 times, then third 3 times. This is the one. Okay, so this is it will do the shuffling 3 times. Okay, of each your data point. This is the only difference. Rest process is same. Now look at the result. This is the feature importance of your linear permutation importance of the, this is not, I think this is only that this title is not this one. This is permutation importance. Now we can see HIV AIDS, income composition of resources, under 5 deaths, thinness, infant deaths. But when we looked at it here, this is also seen same, right? So permutation importance is same, right? So these features are helping the model in doing high prediction. Okay. Okay, now we will talk about the global model explanation. So what is that? So global model explanation, you will apply the SHAP. How would you do? You need to import the SHAP library, shap.init.js, because this is based on JavaScript. You need to load that. How would you now? We will talk about how I have mentioned it to take your whole data set, right? But it's tough to do the like calculations of the whole one. So how we will take it? We will declare x shape is equals to SHAP. This is instance of your library dot sample method x train df, because we can apply it on train data, and number of samples is equals to 500. We are pick up the sample of the data now. Okay, this is the sample of the data of the entire. Okay, but we are going to apply on the entire data set. Instead of taking whole data set, it may contains a 10,000 row, 20 or 1 lakh, right? So instead of applying the importance on that, we will take some sample of the whole data set. We will set the random state. Here we will set the y SHAP value, y train dot location, x SHAP dot index. Okay, why we are doing this? Can anybody tell me why we are doing this?
As for the number of features.
Okay, so we are doing it because I want to take, because I have taken the SHAP, like the sample 500 rows, right? 500 data points. And now I want to take the y SHAP, this means y train data corresponding to those 500 samples. Okay, so it should match with the same data point. That's why I'm doing y train dot location x SHAP dot index. So its index value should match with my this one. Okay, so that's why we are taking this. So you can see, because when you say sample, it may pick up randomly. We don't know from where our data will pick up, right? So that's why we need to do. Now our data is ready. It's a time to apply the SHAP explainer. So we will say here explainer variable is equals to SHAP dot explainer. Here your object. Here we are applying it on the first random forest regression. Remember, you only need one parameter for this model name. Okay. So now we will say SHAP values is equals to explainer X SHAP, Y SHAP. How did you made it? Using sample values. Okay. Now we will plot the summary bar here. Summary plot. Look at this. When you applied the SHAP, it is also showing HIV AIDS at the top, income composition, resources under 5 deaths, thinness 5 to 9 years, schooling, BMI, right? So this means if we go down on the x-axis, it is showing the average impact on the model output magnitude. This is the SHAP values, okay? So this means these features, top 5 features have the highest predictive power as per the SHAP values, okay? This has a higher contribution in the prediction of the model. Okay. So in this, if we say HIV AIDS, right, it is like have a higher value. Till so far, we don't know which value it is considering, why the model is saying like it is contributing a lot, right? If the HIV AIDS cases are more, the life expectancy will go down, right? And if we say income composition of the resources, right? If it's a low, life expectancy rate will be low, right? Positive if it's increasing, right? Your prediction will, like predictive power will be high, but life expectancy rate will be low, right? And then under 5 deaths, thinness of 9 years, and schooling, okay? So these features are contributing the higher prediction power, giving the higher prediction of the model, these one. Now, if you look at this SHAP value will clear you more instead of bar graph only, because it is showing you the positive and negative relation, right? In this, you can see here, more is the red color, more is the, red data points, higher is the
prediction.
But yes, right? Higher is the prediction. But in what way? We will look at the down. Look at this. Here, the SHAP value on this left side, it's a negative, right? On this, the right side, positive. Okay. So here, if we say the HIV value is increasing, right? The prediction power is higher, but its relation is negative, right? Its relation is negative. Why? Because higher the HIV cases, life expectancy will be low. But it is, we are not talking about here the lower high expectancy. We are talking about here the predictive power, right? So predictive power is higher in a negative way, but it is the most of the time this is used by your model, right? Now, if we look at this income composition of the resources, this is going on this side, right? Higher predictive power. But sometimes you can see here, lower income of sources, right? It is giving the lower predictions here, right? Negative here. Here, if we go under 5 death, under 5 year, we can say it is the same. The lower the number of death cases, right? Higher the prediction power. But if the higher the value of your under 5 death, lower is the prediction. Okay. So this is how we need to interpret these results. Okay. But we will look into more detail about this feature, how it is happening, especially about the infant deaths, how it is contributing. Okay. Which value? Then we will apply the local one. So here, if we jump onto this, Here we are applying the SHAP explainer on the linear regression model now. We come down. Now look at this. So in the bar chart, it is showing in random forest, top feature was high predictive was HIV/AIDS. But when I applied it on the linear regression is saying under 5 death is at the top, higher predictive power, right? Infant deaths, then schooling, right? We can see the order of the features is changed according to the model, okay? And then we will go down, look at this. Under 5 deaths, higher the value, right, of these, lower the predictive power because it's a negative, right? It's pushing back, okay? And then this is infant deaths. It's increasing. It's a high predictive power, right? But it is not making any, like if we want to look at this infant deaths, how it is contributing, we need to look at it, okay? Now we will talk about the local explanation. So in this, we will apply the SHAP local. Now what we will do, here we are interested to apply on a single data point. We want to look for the one data point and we will pick up here the infant deaths, okay? So before moving ahead to take that point, we need to reset our index. Because we took the sample earlier from the whole data set, we will reset it into the original one, right? So we will say xSHAP.reset index for the SHAP local, take a new variable, same for the YSHAP. And then we will take this feature only, infant deaths, okay? So if I took the infant deaths, I'm looking at it, just describe how many count, right? How many data points we have. And then here we will saving the index of the most of the deaths, okay? In which data point have a most of the higher count of the infant deaths. So I'm using here IDXmax method to calculate it. So higher value is 449 data point, okay? So we will pick up that location and then we will see the what are the values of other features corresponding to this location, okay? So we will look at this and then we will see the actual result. What is the predictive value corresponding to this? It's a 63.7 predictive power, right? Oh, sorry, your prediction. And now we will plot the SHAP force plot. So when you plot the SHAP force plot, we are plotting based on the linear regression model dot expected value, right? And then SHAP values, we have already created this one. SHAP values, highest number of the death values we will consider here. And then features which we have considered above, right? And now look at the result. This is the base value here. It is like covering up with the actual value. These are at the same position, right? And now if you look, when the infant deaths is equals to 1700, sorry, the value, this is a SHAP value, right? So it is when this is the SHAP value, when it is pushing like in this way, the data points are going into the positive way, right? Higher the value, higher the prediction, right, of this one. But under 5 deaths, 2200, right, it is pushing back to the lower prediction, right? So how these both are contributing? One is pushing towards positive prediction and infant under 5 deaths pushing towards your low prediction. So this is why this was showing us in the above your summary plot. This is the way how model is using it, okay? So like under 5 death cases is this and infant death is this one. Although we say like under 5, we can say infant death is like the death at the birth time, right? It is something when we see the relationship with the life expectancy, we are talking about more adults, right? So that's why this is maybe like using, I'm talking about as a layman, right? The model is using this way. How much positively and how the under 5 deaths is negatively predicting it. Now, if we talk about the same case with the random forest, how it is explaining. Look at this. This is your base value is this, right? Intercept. This is the mean of your that one white range. And here, this is the predicted value. This is very far away from that, right? And now, HIV/AIDS is a higher positive prediction, right? But it is close to the predicted value, right? This is the one. But this, your income composition resources, schooling, this is the one. Under 5 deaths, BMI, all pushing towards the negative prediction, right? How this, we are now looking deeply inside the local, like these things, right? Local explanation. How each feature positively, negatively contributing in prediction of the model. Okay. What questions do you have till so far?
Just one quick question. I know the random forest model we're currently viewing, this model itself is a black box model, but it does not affect how we will be able to evaluate the importance for each input for each feature, right?
Yes.
And that's the same thing for if we apply a neural network model.
Yes. Yes. Neural is also black box model. All right, now we will jump on to the line tabular explainer. This is only and only used for your local explanation. Okay, we are not talking about here anymore global one. So here you will import this package line underscore tableau, line tableau explainer, and then we will prepare the data, SHAP local values, features name, and mode we will use regression first. Then look at the result. This is you need to use lime explainer dot explain instance. Now look at the result. This is your predicted value from the minimum to maximum. Okay. So now this is negative. This is positive. This is your actual features and their values. Okay. And these you can see your this line is saying if your HIV/AIDS value is between the range of minimum 10.10 and we are not showing here the value, then it has a higher predictive power. Okay, we can consider it here the 30, so it may lie between this range. Okay, so this is the specific value. We are looking at the specific data point, and this has a higher predictive power at this point. Okay, and other income composition, these all features doing the low prediction. Okay, at the same, this is measles doing the higher prediction. Okay, so the line is looking for the specific data point in a of a one row. Okay, it is telling you this is the actual, like here the values, and when you apply the line, how it is how the features are contributing based on the calculation of the values. Okay, negative, higher positive prediction power, but others are pushing down it to the less prediction. Okay, less negative. So this was all about like today's code along. Okay, and in this, I will jump back. Oh, sorry, I will jump back to my slide. This is the temperature check. If all of you can just fill it, it will help me to know how much did you understand from today's lesson. I'm expecting more.
Are you gonna post this code along right after the lecture?
Yes, it is already posted. It is in
Okay.
the stack schedule as well. And
Thank you.
if you want, I can share the link here as well. And you have a link here. Okay, so the summary of the class was, what is the permutation of the importance? This is we have discussed. What are a global and local model explainers? Okay. And in the next class, we will start with the introduction to time series. Again, this is the very good and interesting topic as well. Okay. Now, if anybody have any question, please feel free to ask about today's lesson. Any confusion in local and global? I am going to stop recording.